Okay, time's 12:30, so why don't we begin here? First of all, are there any, let's say, general questions about the course in terms of what we're going to be doing, about the grading or anything like that before we get going on the R part? Okay. So something came up today, unfortunately, about just like an hour before class that needs my attention after our class. So my office hours are going to end at 2:05 today, but please feel free to email me or if needed, set up an appointment with me if you were needing to talk to me for an extensive period of time during my office hours today. That week number 1 quiz that all of you completed yesterday or by yesterday, was obviously you were just providing information to me, very useful information. Everyone received 5 out of 5 points on it. You will see the grade posted to Canvas. Okay. So let's talk about R. So, one of the things I look at in this quiz was everyone's R experience. And, based upon what I was kind of telling you yesterday or Tuesday, we have a wide variety of backgrounds in this class. There's a wide variety of R experiences in this class. Now, this one class that we're talking about, that we're doing right now, is not going to make you an expert in R. But hopefully it starts setting you up for success in our class. During the semester, and especially early on, I will take a lot of time going through code line by line for certain parts of our class or in class to help you. Part of this will also be showing you how you can learn the R code on your own so that when you come across something that's not familiar or you don't understand necessarily how to do it, you will have the tools to figure out how to do it. Also, if you've taken a look at my course website since we last met, you will see that there's lots and lots of R programs there. There's probably thousands of lines of code. I haven't actually counted it all, but I would imagine over thousands of lines. You can think of my code as a template for your own code. Typically what we will do in this class is that we will analyze a data set, applying the stuff that we're learning about. Okay? Outside of this class for a project or maybe a quiz or even a test, you will often be performing similar analyses. And so you can think of my code, that thousands of lines, as a template for your own. And that allows you then, if you take the time, allows you to then learn what each line of that template is actually doing. Okay. So at the beginning of class here, I have just about, I'll estimate maybe 15 minutes worth of stuff about Introduction to R. And then I will turn it over to you guys to ask me questions. It might be where, you ask me questions with everyone else here in the room, or it might just turn out to be, in terms of I'm up here and answering your question, or it might just turn out to be that I go to where you're sitting and help you do something that maybe you were having difficulty doing from last Tuesday to now regarding R. So, there was basically 4 different parts of my R set of notes, and that's how I've kind of organized some of my material here. And I've tried to organize some of it in terms of questions so that we can interact, and that might then lead you to other questions. And so a question that I could actually put on test number 1 is simply something, I think, relatively simple, but it might be hard to actually put it exactly into words. And that is, well, what is an R package? What would you say an R package is? How would you explain it to somebody?
I'd say a set of functions that's already been written by somebody else that you can download and then start using those functions on function.
Exactly. So a set of R functions, also data as well, kind of all packaged together. Sorry to use the same terminology, all put together. And you can then download it. The number one place to download it is the Comprehensive R Archive Network. That's essentially run by what's called the R Core Team, which is a group of about, might be about 20 statisticians now, that control R, all volunteers. And so you can download it to your own computer and then use these functions, use these data that other people have created. You can use them. There are, I looked this morning, over 20,000 packages out there. And the reason why there's so many is because a common way that these come about is that somebody will do some research, maybe develop a new statistical method to do something. But they want to be able to distribute it to others easily. And so what do they do? They create some functions that, do like a model fit or some kind of analysis. They create some functions, put them all together into a package, upload it to the Comprehensive R Archive Network, and it makes it then downloadable for others to benefit from it. And that has been one of the reasons why R has become the number one statistical software package out there, is because of that. I mean, back when I was in your situation of being a student, you would come across, I'll do an example from graduate school. You come across a new statistical method, you read a paper, it's like, wow, this is really cool, I'd like to be able to implement it. But you wouldn't be able to immediately, at least. You would have to figure out how to program it in all yourself, which obviously if you're new to it, you're not necessarily probably going to get it right at first. And obviously also it takes a lot of time. And so the ability of putting R packages out there has really sped up the development of statistical methods. So I just, simply here, just kind of highlighted some stuff in black so that we can see, so that the answer's not immediately out there. I am actually the author of 2 packages. So if you go to CRAN, you'll see my name out there. And basically what it is are packages that I have created corresponding to my research. Other people, statisticians or non-statisticians, who are analyzing data, well, then download it and use it. And sometimes they'll ask me questions about it as well. Now, if you're using RStudio, if you want to install a package, it's fairly easy. You can simply click on Packages, Install. You can type a particular name that you're interested in. There's ways that, well, typically you know what the name of it is beforehand. You can actually go to, where is it? Sorry, I had it up earlier. You can go to CRAN, come over here to Packages. I usually go by table of available packages sorted by name. And if you're looking for something that, let's say, does, let's do factor analysis. This is one particular topic that we're going to be interested in. Let's see what happens. So we can see factor comes up if I do a little search. And if I do factor and for factor analysis, you can see that there are 51 packages that deal with something with factor analysis. And so that's a way to find information or packages that might be helpful to you. Another way, sorry, I'm kind of going off my planned set of stuff here. There's what are called CRAN task views. And, when you have 20-some thousand packages, it can be hard to find what you're looking for. And so you can go to the CRAN task views, and you can see certain things are organized by a particular topic. So for example, let's see here, one that would be relative to our class. If I can find it real fast. Well, some of the machine learning stuff, that would be one. Yeah, at least off the top of my head, that would be one to look at. Okay. Now, while you can use point and click methods to do what you need to do in terms of installing these packages, what I find at least is a quicker way to do it is simply to use the function called install.packages. That wasn't in my notes, I don't think. So for example, let me go over to just the R console window, and I have recently installed a new, the latest update of R, and so I don't have a whole lot of packages installed yet. So if I say install packages, parentheses, quote, one of my packages, bin group 2, in parentheses, or I'm sorry, in quote, in parentheses, then what will happen is what R is going to go to is a default location. There's many different locations where these packages are stored around the world, and we'll go to whatever's set as your default location, find that package, download it to your computer. Now, many packages rely on other packages as well. And so if I want to install bin group 2, you can see that it's actually, I guess we just go up here. You can see that in order to use bin group 2, I also need all these other packages as well. And so especially if you have a brand new installation of R, you're going to go through this a lot. There's tons of stuff that are downloaded at the same time. Okay. Now, if I wanted to use functions or data from that package, what would I do? Can I use it right now from this bin group 2 package? No, I can't. What function do I need to run to say, hey, R, I want to use functions from this package? Does anyone know what the function is?
Is it library in parentheses?
Yeah, exactly, library. So you always have to do that first before you use functions from the package. Now, there are some packages out there that are actually pre-installed into R that you do not need to do that. Like, for example, like the stats package that we used on Tuesday. Notice I did not ever say library stats, because those are already ready to go. Okay, so if I say library bin group 2, then I can start using functions and data that are actually stored in that package. Okay. So next then here, a question that actually I posed, I think, in the last class is, why is the last line of a function so important? And the reason is because that is the line, or that is the information that's actually returned to the user after you run the function. And so we looked at an example of the SD2 function that we wrote that returned the standard deviation. But you can have multiple sets of information that are actually returned to you if you want to. You'll see examples as we go along during the semester, but it's always that last line. Now, some way that we verbalize our code when we say it out loud. So for example, when I do something like this, save, then less than sign dash 2 plus 2, that less than sign dash is often verbalized as the word gets, G-E-T-S. So save gets the results from 2 plus 2. So we can see 2 plus 2 has an arrow that's going to the left. Well, to my left. This is your left. And so it says all those results are going to save. Often in how we program in R, we often will separate multiple words by a period. have to do that. Sometimes people will use what's often referred to as camel case, and they'll say my value for an object name, or which could be a function. It could be just some object that's storing some information like 2 plus 2. People could use a camel case like that. I think used more often in R, at least this was the original way that people were doing it, is to use my period value, but people typically verbalize that as my dot value rather than say the word period. Okay? So in the second set of notes, I started talking about program editors. And for those of you who did have experience with R, I would assume that the vast majority of you, it was with RStudio. RStudio will work just fine in this course. And I won't get into, again, the reasons why I prefer not to use it. But RStudio is just fine. I think just in general, there's just so much stuff that you can do with RStudio. It's actually, to some respect, a disservice to people who are new to R to actually use it. I wish there was, at least more generally known, a simple, easy editor that has some nice color coding of the code so that people can start with that. And then as you get more advanced into R, if you prefer, you can use RStudio to take advantage of some of the stuff that's in RStudio. But I typically use TIN, which stands for TINN, which stands for This Is Not Notepad. I typically use that, and I demonstrated in some of the videos where let's say if I wanted to read in a data set. We can talk about reading in data sets later if needed, because I know sometimes that's a place where students will struggle a little bit. I can just simply highlight some code like this, like I'm going to estimate a regression model, come up here to a little button. Oops. Come up here to a little button. Oh boy, that's not helpful right now. Come up to a little button and press it, and all my code is automatically transferred into the R console. So there's other ways to use TIN as well. So if you do like the RStudio format where everything, at least by default, is embedded into one window, you can actually do that inside of TIN as well. If you want to know more about that, I'd be happy to explain that. Okay. So the third set of notes dealt with an example, and where we had some data. I've been teaching for quite a few years, 30 plus years. And one thing that I've been very interested in terms of student backgrounds coming into my classes, what I've noticed over the last 5 or so years, is that sometimes students will struggle with what I had originally thought would be an easy thing, and that is to actually read in data into R so that you can start analyzing it. Where students trip up is understanding, I have this data here in my documents folder. How do I get that data ready to go in R? Well, one way, in TIN, you can, let's see here. There we go. Import data set. I typically use the base package to actually import data, to get data into R. So I'm going to click on that. Up pops up a window. I find wherever my data is stored. Let's see here. And so I have some data that's called gpa.csv that I talked about in my example. And I can just click on that, click OK. And it asks me, how do I want to import it? The defaults will work, so I'm not going to go through all that. And now I have my data into RStudio. Not too difficult. Depending upon how you're using RStudio, you might have to actually do that every single time that you open up RStudio and you want to analyze that data set. A better way that I find to do this kind of stuff is just simply to use the corresponding code that would be needed to actually import it. And so let's see now. There's a few different functions that can be used. One's called read.table. This is about one of the most general functions out there. It's called read.table because I'm reading let's say, in a table of information. My data is stored as kind of a table where I have columns that represent the variables. Where at the very top the very top row is the actual variable names. Let me actually show you that as well. Now, this was done in the video, but let me, I do want to spend some time on it. Let's see here. There we go. So this is actually a very simple file. It's a plain ASCII text file where space delimited. So space meaning that spaces are between essentially the columns of information. We will often be using comma delimited where you have a comma there. But the key thing is that you notice that we have the variable names at the top and then we have the data down below. So like I say, read.table. And the number one problem that students find is how to specify the actual place where it's stored on your computer. In this particular case, my hard drive on my computer, I have the data stored there. It's the C drive. And I specify the actual physical location of where it's actually located. So it's stored in a folder called data that I've actually created. And there's the actual file name. Now, I've had students, and if this is you, this is fine. I've had students ask me, well, how do I know that indeed that is actually the physical location? Well, if you can see where that file is in, let's say, and again, I'm using Windows, it's going to be similar in other operating systems too. If I can see the actual physical location in Windows, what I can do is right-click on it and look at Properties. And where is it? Yep.
When you right click, it has the option of copy path.
It does?
Yeah.
Okay. Well, if you wanted to actually see it, we can see where it's located right there. I know that's small, but it says C:/data. Okay. Okay, copy as path. And there we go. Thank you. Now notice how this is how it's actually written here. We have these backslashes. Yeah. Backslashes in Unix or Linux actually has a different meaning. And so because of that, and people were all first creating this in a Unix kind of environment, they said, okay, in R, we're going to use a double backslash instead. Or you could use a /. Okay? So the number one problem that I've had students find, again, is finding where that location is. And if this is new to you, hopefully you can learn from that. If it's still not clear, just let me know, and we can talk about it some more. So at the very top here, I have header equal true, corresponding to my variable names were at the very top. And then SEP stands for separator. How are the columns separated? Well, they're separated by spaces. You can actually, not actually put a space there, but you can put quote, quote versus quote, space, quote. R knows what that means. And there we go. I read it in. If I type GPA, you see the actual GPA there. So what kind of data format is this in terms of R's terminology? What does R call this, this GPA, this object? Does anyone remember from the notes? Text? No. I'm actually looking for the formal name that R would call it. For those of you who have experience with the tidyverse, it would be something like called a tibble, but I'm not using tidyverse here. It actually has a different name in base R. Anyone know? So it's data, right? It's kind of a frame of data, so it's called a data frame. That's the official name. It's just good to make sure that you are familiar with these official names. I try to use them as much as possible. Rather than saying, here's my data set, I'll say, here's my data frame. Okay? Now, if I wanted to access part of this data frame, what could I do? Let's say I just wanted the first column. What could I do? If I wanted to print it to my screen, just the first column.
You have to remember it's the name of the data frame that is the
Oh, yeah.
Multiple ways you can do it.
Yeah, there's multiple ways.
Yeah. Not using the not sign also. If you have two columns and you want the GPA on the edges, so you write exclamation mark, then not.
Yeah. So let's go over a few here. So the most conventional way that people will use is GPA $, the name of the variable, hs.gpa, which stands for high school GPA, and there comes back to my screen. So for some reason, people who have gotten into the tidyverse, and I'll talk more about this tidyverse thing later, have frowned upon or have had a strong dislike of people using $, despite it being prevalent in the use of R and then also previously S for tens of years. So I could also go, think of it as, for those of you who have experience with a matrix, you have rows and columns of a matrix. I want column 1 of the matrix. And so I can say GPA, I'm not going to put a bracket, then I'm not going to put anything for a row number. Actually, let me put a row number there. If I do GPA, 1 for the row, comma, 1 for the column, I get row 1, column 1 in that data frame. If I leave off then that row number, now I get the whole column. Let's say I did this. What's going to happen?
The other column.
Doesn't work. Very often an exclamation mark can mean the logical not.
Yeah.
It depends upon the situation when it will work. Instead, if I do a minus sign instead, now I got just the second column. So for example, 2.6, 2.6. Okay? Let's see now. Other ways that are less used, but still interesting to know, is I could put the variable name for that column designation, and I will get just that column. It's used much less often. I rarely would use it. But that is another way that one could do that. So you can even get more complicated. Let's say you're just interested in those observations that for people with a high school GPA greater than 3.0. So what one could do is as follows. So GPA, hs.gpa. Okay. Now if I go greater than sign 3, look what's going to happen. I have a bunch of trues and falses. And so this is one of the beautiful aspects of R, is that it will actually perform operations on what it refers to as vectors of information, where it's applying that greater than 3 check on the whole 20 different observations. There are 20 rows to this data set, data frame. It will apply that same idea to all 20 simultaneously. Now, if I then combine those trues and falses with saying I want to only pick out certain rows of my data frame, so notice what I put into that row number part, that first index, what's going to happen is it's only going to then return to me those observations that have a GPA of greater than 3.0. So where is this useful? Well, let's say, for example, you have a data set and you have some unusual observations that you're detecting in a plot, and you want to know more about those particular observations. Here's how you can simply pull those observations out of the data frame and take a look at them. Through using this logical check, put it in for the row numbers. That's something that we will use this semester. There's other ways to do it too. Some of you might have learned about a function called subsets. That will do it, for example. But I think this is, I usually use this way. Okay. Now, last time, this is a now review from last time. So let's say I have a particular function and I want to see the actual code that's used inside that function. How would I do that? Let's say I'm interested in the LM function, which was used in the notes to estimate a regression model. How would I actually look at the code that's doing the calculations inside of LM? What would I do? Well, I guess I already have it there. If I just hit enter, if you just type the function name, here's the actual code that's actually being used to do the calculations. Note that I did not do LM parentheses and parentheses. Rather, I just do the function name. Okay? Now, for, I would say probably most of you, reading through this code is going to be a little bit difficult. I shouldn't say a little bit difficult, a lot difficult. One thing that you can do, this is maybe more advanced than what we really need to do for us right now, is you can copy and paste that code into an editor. Okay. Then notice how it has like an argument called formula. Actually, say formula equals whatever you want it to be. This was to fit a regression model. If you remember in the notes, it was like college GPA tilde high school GPA. So I could actually put in that model formula here. I could actually put data equal, whatever it is, my GPA data set, put that in there. And then what I can do is then execute this line by line and see what's actually returned. That's a great way to learn really the guts inside of R, how it's working. Because you can then figure it out. This is what this line is, this is what this line does, and so on. Learn from that, and then you can start using that information then for your own coding. If I come now to the bottom here of that function, we're not. I think I copied it twice. That was the problem. So if I come down to the very bottom of this function, remember how a function, all the code is inside of curly brackets? So we can see the bottom curly bracket here. And so what's returned to the user is something called Z. And you start seeing some parts here where Z $QR, Z $Y, Z $X. What that's creating is what's called a list in R's terminology, where this list has certain components to it. One's called X, one's called model, one's called Y, one's called QR. And since Z is given as the very last line of the code, that's what's going to be returned to you after you run the function. So if I come over here, oops. Let's try this again. So here's the corresponding program GPA.R that was in the notes. I'm going to estimate a regression model that uses college GPA as the response variable, high school GPA as the explanatory variable. Some people call it independent variable or covariate. My data is in GPA, so if I do this, all that stuff that was in Z in that code is now in mod.fit. And so if I want to see a list of what is actually in mod.fit, what could I do in terms of this command prompt? There's information that's given in the help that will show you what's there. But if I just wanted to look in right now from this command prompt in the R console window, what would I do?
Without parentheses, I think if you enter.
If I just did mod.fit? Well, not exactly. And that's often for people who are new to R, you might be thinking, oh, it's all going to be there. I'll explain a little bit more why this occurs a little bit later. But there's actually something else that you can do. Perhaps, for example, you want to learn what the names are of the things that are inside of mod.fit. So I can just do names, mod.fit, and here we go. Now we do have a list of everything that was actually stored in there that was basically that Z that we saw inside that function. So if I do mod.fit $coefficients, I see what we often refer to as the beta hat 0, the beta hat 1, the estimated y-intercept, the estimated slope of my regression model. If I did mod.fit $residuals, then I have my usual residuals from a regression model. Now, if I did summary mod.fit, it summarizes what's inside that list. But if you notice, if I did summary GPA, and this is just directly from the notes, if I did summary GPA, notice I get a different result. Does anyone remember why I would get a different, even though I'm using the same function here, why do I get this different result from saying summary GPA versus summary mod.fit?
Because in summary GPA, it is applying directly on this basic data set which was in the GPA data frame.
Mm-hmm.
And when you wrote the summary of that mod.fit, it is applying on the data frame which had so many columns or calculated by that function of ln.
I think you're getting the point. Let's not call what mod.fit is as a data frame. It's actually not a data frame. It's actually a list. It's just terminology. Okay. But what happens is that the function summary sees what's stored in mod.fit is different than what's stored in GPA, and so it behaves differently then. And this gets into one of the biggest things to get out of understanding R, and one of the more difficult things for introductory users is that R is what's often referred to as an object-oriented language. What that object is going to then cause a function to behave differently. And this gets into then the last, or the fourth set of notes that I have for the introduction to R. Every object in R has what you could call formally an attribute to it, a class to it. So GPA has a class called data.frame. So that tells R, hey, this is the form of what's inside this object. And if I do class mod.fit, notice I get a different result. It has a class called LM. Now, it's sort of a coincidence that it's the same name as the corresponding function. It doesn't have to be. Most people who program in R and create their own functions, they will use a very similar name to the name of the function for the class. But we see we have a different class to it. And so in R, there are what are called generic functions. Functions that can behave differently depending upon the class. Summary is one of these generic functions. And so when I run summary, the first thing that this function is going to do, actually, I bet we can see it. Yeah. Here's the actual code inside the function. You can see it's very, very small. And the reason being is because it uses just simply one function inside of summary called useMethod. What it does, this useMethod function says, okay, let's find the class of the object, GPA or mod.fit. Let's find that class. And then what we're going to do is not execute summary anymore. Instead, we're going to execute a new function called a method function called summary.lm for LM class objects, or summary.data.frame for data frame objects. So for example, if I were to type summary.data.frame GPA. Let's try that again. Actually, I'll tell you what, let's just do this one. Summary LM. I'm using the wrong object. That's my problem. Notice what happened here. It gives me exactly the same output as what we saw from just summary. Because, and I'm going to say this again. I'm going to repeat myself. What summary mod.fit, the first thing it's going to do is going to get the class of mod.fit. Then it's going to try to find a method function called summary.lm and execute that. Because that's meant to be working with these objects that are returned from LM. Summarizing a regression model output. And so I can type summary.lm and I can see all the corresponding code that went into it. And so, for example, let's see here. Notice how you see combined together. We saw the C function last time. It combines information together. We see estimate, STD period error for standard error, t-value, probability dealing with a p-value. Standard kind of things that you see any statistical software package for regression output. And if we actually look at the output, there it is, right there. Okay. Now, if I did, let's see, summary.data.frame, here's what happens when I run summary with the object that has a class of data.frame. It goes and tries to find this particular method function. And so, for example, let's see here if I can find one quickly. And I'm not going to have a good example, unfortunately, from quickly looking at this. But again, here's then the corresponding output that's actually generated. Okay. So we have went over this. I'll just show you. So what is a class in R? Every object has a class attribute to correspond to the type of information that's stored within it. The class of an object can be used or can be determined by using the class function. Why is R often referred to as an object-oriented language? Functions are typically designed to operate on only one or a few classes of objects. We have these generic functions. We have these method functions. Yes?
Is there a way to write a code or is there a way to tell what classes are accepted in what parameters?
Yes. So let's see here. I think I often forget the exact function name, and I want to double check to see if I have it there. Yeah. So there's a methods function where if you put the class name, you can see then the corresponding excuse me, functions that are set up, generic functions that are set up to work with a particular class. And then you can also use the methods function this way. Generic.function equals summary, and you can see all the corresponding method functions for that generic function. Okay. So a few more things here. Sorry, I went a little bit longer than I anticipated. So there's something called the tidyverse in R. And if you go to the webpage of tidyverse, you will see the wording of something like an opinionated set of R functions. These were created by the RStudio people. And they have widely promoted them. And that's helped them gain a lot of traction in the R community because of that, because we have this for-profit company that's actually promoting this. Now, this tidyverse, again, it's a set of packages that help you do stuff. Like there's a package that many of you maybe have used called ggplot2 that does graphics. There's other packages especially that are helpful with respect to getting data into a format that you want to use. For some reasons why I mentioned on Tuesday, I typically do not use stuff in the tidyverse. You're welcome to use stuff in the tidyverse if you know how to use it from other classes or other experience, but I will not be using that here. I just wanted to point that out to you if you wonder why I'm not doing certain things. Basically, what has happened now, since the tidyverse has been around, it's basically RStudio has formed its own dialect of R. I don't think that's a good thing, to be honest. I'd rather us all communicate this with the same language. Now, I'm not the only one who feels the same way about tidyverse. People will refer to people like me as a tidy skeptic. Probably one of the leaders in this area is a guy by the name of Norm Matloff. He's a former editor of the R Journal, former professor. He actually has his background's more computer science, although he's gone into lots of statistics and stuff. And he has a very nice document that I largely agree with, about tidyverse and why we are skeptical about it. Generally speaking, we feel as though that there's better ways to do this stuff. And often, especially for people who are new to R, this is not where to begin. It's easier to learn other parts of R first. So if you're interested, you can take a look at that. Now, if you're looking for other ways to learn R beyond R class, I've taught, and I was actually the one who developed for our department, Stat 850. So it's a graduate level course, but it's meant for first year new master's students in statistics. The topics that you will see in this, you will often see very similar ones in Stat 151 and 251. And so 1/3 of this course is an introduction to R. And so you're welcome to take a look at that. I have lots of notes on my website. I have videos of me teaching the course too. I want to remind you that there's practice problems for each subsection of our course. There are practice problems for the R introduction section. One, the big portion of it is a data analysis that I've used previously in an introductory stat course where we are fitting a regression model. I would expect all of you to be familiar with those regression models that are discussed in that. You may or may not be familiar with how to do the R parts. That's the purpose of the practice problem. There's similarities to the GPA data set that you saw in the notes. There is one part of it that, given what I've seen now for your backgrounds coming into this class, you may not be necessarily familiar with, and that is how to work with qualitative variables, categorical variables. Let's say, for example, I think in this problem it deals with the let's use a different example. Suppose that you want to, let's see here. So one example that we will take a look at later this semester is that we want to estimate the probability of success for a field goal in football. There's a number of factors that might affect the probability of success, and you'd be able to predict, is it going to be a success or failure as well, in addition to the probability. One factor might be the weather, where let's say you have categories for your weather, such as it's raining, it's snowy, it's, let's say, perfect conditions. And so, you might have, let's say, 5 different categorical variables associated with it. How do you actually incorporate a 5 categorical variable, into a regression model? Let's actually make it a little bit simpler. Let's say that we have 3 categories, okay? Let's say it's category A, B, C. What you can do is create what are called indicator variables, where you always create one indicator variable less than the number of categories that you have. I won't get into the reasons right now why that would be the case. And what R would do in this situation is do this, where basically what you're doing is you're creating, it's called an indicator variable because it indicates, are you in category B or not? And the way it does that is by saying, I'm going to create a variable called x1 that's actually in my regression model. That's a 1 when you have it category B, a 0 otherwise. So it indicates category B or not. x2 is going to be another indicator variable where it's going to be a 1 for category C, a 0 if it's not. And so your regression model, I'm going to use what would be the standard notation that people would use. Would be something like this, where the expected value of y, where y could be, let's say, your response variable, y is, let's say, a 1 for a success, 0 for a failure for a field goal. And I want to know what's the expected outcome. What's the expected value of y? My regression model would be beta 0, my y-intercept, plus beta 1, a slope parameter on my first indicator variable, plus beta 2, a slope parameter on my second indicator variable, x2. And the reason why I create a model like this is as follows. Because let's say I'm at category B. Notice my model becomes that. x1 is a 1, x2 is a 0. If I had category C, my model looks like this. And if I'm at category A, my model looks like this. Notice each of the 3 categories represents a unique coding for what your model would look like. That's how you work with regression models when you have qualitative or categorical variables. If you haven't seen it before, hopefully that will help you with the practice problem. We will see many other examples of this kind of stuff as we go along in the semester, and we'll come back to that. And so what's next then in our course, and then I'll ask for just general questions. I have my office hours, reduced office hours after class. On Tuesday, September 2nd, we will do an introduction to matrix algebra. In general, it looked like about 25% of you have no experience with matrix algebra coming into this class, so this will be helpful. Some other students have a little bit of experience, but not much. I would say probably at least half the students have taken like a Math 314 course, which is a whole semester of matrix algebra. So we will do about a day and a half on matrix algebra. What I recommend that you do when you come to class is you have on your computer my set of matrix algebra notes, and you can simply type in notes as we go along during classes. I go over those notes with you. Often during class, although this isn't going to be the best example, often during class I will be asking you questions, and this will give you an opportunity to type your answer to those questions in the notes. there will be more questions in other material, but there will be at least some with the matrix algebra part. Sometimes students, what they'll do is actually print off a copy of the notes, bring it to class, and just simply take notes on that. Then on Wednesday, September 3rd, the week number 2 quiz will be due, and that's basically over this introduction to R stuff. Okay. So, sorry, I ended up taking a lot longer than I anticipated. Do any of you have questions about R that we can discuss as a group? If you're not comfortable with doing that, then we can simply also, after I end class, then we can also discuss individually. So, do any of you have questions? Now, again, there's a wide variety of backgrounds here, and I hope you're not in a situation right now where you're starting to say, boy, what Chris was talking about with R is quite complicated. I'm worried. Please don't worry. Again, we will go through the R stuff slowly as we go along in the semester. But there is some responsibility on your behalf to really start getting into this, because you need to be able to communicate within R to actually do statistics. Are there questions? Yes.
You talked a little bit about tin. Could you introduce us to it a little bit more?
Sure. So, is this, at least at the beginning of class, I went to the back of the classroom. I thought that this font was big enough. Is it big enough in the back of the classroom? Okay. So, TIN again stands for This Is Not Notepad. It's actually written by, the main writer of the package is a professor in Brazil. And this has been around for at least 20 years. It actually predates RStudio, although I didn't start using it until about 15 years ago. And this is not necessarily exactly what it will look like when you download it and install it on your computer. Note that it is only for Windows-based computers, but this is very similar. I've just done some modifications to the color coding here. So if you notice, for example, the way that I like to operate with tin is I will have all my comments in R. A comment starts with a pound sign. I have them with a gray background to it. I think it's really helpful for me to see what's going on. And if I wanted to change that for some reason, I can go under Options, Highlighters. Yep, Options, Highlighters. And here you have a way to make changes to how the color coding that's actually being done. RStudio has similar things, but I don't think it's necessarily always as easy to do. Unless you're doing some really basic stuff. And so that's why this looks maybe a little bit different than what you see in the actual notes. Now, there's some key buttons here to work with. And let's do an example here. And I kind of demonstrated this before. Let's say if I just want to run a segment of code, I can just simply highlight it. And I come up to what is the third button from the left up here on this toolbar that says R Send Selection. So what that means is if I click on it, it sends it to the R console window. And the R console window, if I send code to the R console window, I want to see what the output is immediately. Unfortunately, what the default is let's see here. Where's that? I was hoping I could find the icon for it, but I'm not going to be able to real fast. There we go. What the default is, this will happen. So I have some code that's highlighted. I'm going to send it to R console. Notice what happens. The R console window disappears. And if you're not, let's say, working in a nice multi-monitor environment, if you come up to my office, you'll notice I have 3 monitors plus this one here. And so the way that I usually work is I have my tin in one monitor, and I have my R console window on another monitor. But if you're just working on just a plain old laptop like this, then it can be very frustrating that the output that you just got, you can't see. And so you need to specify to TIN, hey, I want the focus to be on what's in the R console window. And to do that, there's this little icon up here that says Options, Return Focus. And so if I click on that and rerun that code, now we see the R console window pops up or stays there. Instead, another way to make that change, you go under Options, R Focus. So it says RGUI, meaning R GUI, the R console window. Okay. Let's see here. Now, over the last couple years, the authors of TIN-R have made it a little bit easier to use R, let's say, within this same TIN-R window. And so if I highlight this and come over to, actually, I don't want to do that part. Excuse me. Let me actually close. Okay. Let's actually, excuse me. I'm going to just close out R. You can actually open R from within inside of TIN. And the way to do that is if I come up to where we see R here, where it says R Start Close, I click on that, then I have two options. The one I usually choose is the R GUI, and that's where I get what I was working with before. What happens is once I implement that, what's going to happen is that R will automatically run a particular pack or load a particular package that's set up to make this connection between TIN and R. And so especially the very first time that you ever use TIN and you ask it to run R, you will see a new package that's being actually installed. It will automatically do it for you. And so once you see the start socket server true, meaning, hey, you're set up, you're connected. Now, another way to do this, to run R, is if you click on R term, then we have this. Now you're starting to see a little bit like what you kind of have with R Studio, where, yeah, I don't normally use it. Or actually, I just updated TIN-R as well coming into this class, and so I hadn't actually used the terminal version of R yet inside of it. But now you can see everything's embedded inside of one system here, and I can again transfer code just like I did before to the terminal window. There are multiple ways to actually interact with R, and it's really beyond our interest, I think, in this class to get into them, but there's a terminal way, there's a GUI way, there is ways like, for example, when I use the supercomputers on campus, I can actually basically say to the supercomputer, go run this program I've run, and I don't ever see an R window pop up. What it does will actually write some output to a file that I can execute. The top of my head, I cannot remember exactly what that version of R is, but it does exist. And so there's different ways to interact with it. And TIN-R also allows you then to have a terminal plugin. And one thing that you can see here is that you can see how some of the color coding actually extends to this version as well. There's ways to, let's say, run the whole program at once. So if I say rsend file, unfortunately it's not working right now, but you can actually send the whole program all at once. And so you can just kind of explore on your own the various options of how you can interact with R in terms of sending code from TIN to R. That gives you some background. To some respect, it's like, okay, let's click here, see what I have. Let's click here, let's see what I have. We could do hours of this. But what I've tried to do, at least in the notes, was to highlight what I thought was the most important for students to use. Now, I have had students take this class or other classes. They will simply use this version of R that I first introduced last time, and they will use the program editor that comes embedded inside of R, and they will just simply use this all semester. I really wish that R would make this editor a little bit easier. I mean, in terms of like the color coding of a code or stuff like that. I don't know why they don't want to. This actually editor didn't always exist in R, but if I highlight that code, come up here to edit, let's do run line or selection, you can see how it behaves very similarly to what Tin did. So you can use that as well. I think for the length of some of our programs, you really will appreciate the color coding of the code to understand or to be able to read the code better. Are there other questions? Yeah.
So for this course, though we know that what's wrong with the RStudio, but if somebody has learned it initially with RStudio, there is no issue. Keep using the RStudio.
Yeah. The key is you're still using R. All that RStudio is a user interface. I prefer a different user interface. That's all. Yeah, make sure though that outside of this class, if let's say you're using some research or some place where you need to cite a software package, actually cite R, don't cite RStudio. Yes.
So when you're going over like the GPA data, and when you're doing that one function where you had like the closed bracket, comma, and then one or however you wanted to delineate that, it kind of gave like that whole string of numbers at once, so include like the 1 and 18.
Mm-hmm.
Is there a way to make that look like the original data, where it's just like a column vector, or just maybe like college GPA?
Let me actually read in the data. Actually, I don't want to use the terminal anymore. Oh well, we'll just go with this. Okay. So we have, let's see here. So I think your idea is, okay, I'm not a big fan of it just being one string. In the grand scheme of things, it's not that big of a deal. But you can think of this, and this might be get into the matrix section too. In R's terminology, GPA $HS.GPA is actually a vector. It's not a vector in a true mathematical context. So if you've had like a whole matrix algebra course, it's not exactly like that. Just think of it as a string of numbers. Okay? But if I use functions that are set up to do matrix algebra, so for example, there's what's called a transpose in matrix algebra that allows you to take, let's say, a column vector, make it a row vector, and vice versa. And so if I do that, well, it didn't do it exactly the way I wanted to do it. Let's see. There we go. So I think what happened was it needed to convert it to yeah. This is going to get a little bit more complicated, but that's okay. Yep, I was right. Okay. So when this T function stands for transpose. When the T function then works with that set of numbers there, it says, oh, T function is meant for matrices. There's actual there's actual class of an object, just like what we saw for data frame, just like what we saw for a list, or like the mod.fit part. There's an actual class called matrix. And so when the T function was invoked, it transformed the stuff that was in $HS.GPA to a matrix. And I bet I'm not going to do this right now, but if you look at the internal part of the T function, you're going to see the very first thing that it does is run a function called as.matrix, meaning treat this as a matrix. Okay? And so then when I did a transpose of that, this is what we got. So as.matrix already did make it one column. And so then when I did that, there we go. That's how we got it. Now, another way to do this is just create a new data frame that has, as a variable, I'm not typing very well. This is my problem right now. There we go. So I could have done that way. That's a long explanation to a simple question. Are there other questions? Okay. Why don't we call it a day? I can stick around and talk to any of you individually about this up until about 2:05. There is another class that comes in here, so we might have to end up going up to my office. Okay? So that's all for today. See you on Tuesday.